coefficient of d to the power 1 and 1 is the coefficient of d to the power 2. Okay, so we have got 1 plus d square as g1d. Okay, now as same as we can generate g2d. What was g2d? 1 1 1. That means for this 1 is the coefficient of d to the power 0, 1 d to the power 1, 1 d square. So we have got g2d as 1 plus d square. So ultimately we have got g1d and g2d in the polynomial expression. Okay, so we have generated the impulses g1d and g2d. So that impulse responses, which is basically according to the C1, that means this C1 and C2. So we have to write this ultimate impulse response, that is capital GD, in form like this. That means G1D and G2D will be in the side by side. Okay, so we are placing this side by side. That means 1 plus d square and 1 plus d square. So now it's time to calculate the CD, our expected convolutional code, which is nothing but the multiplication of the message input and the impulses. Okay, so MD we have already previously calculated. That means MD equals to 1 plus d to the power 4 plus d to the power 5, which we have calculated from the given input bit representation. Okay, then what is the GD? GD equals to this. So I have written this. Now to multiply this, we have to just follow this procedure. That means this MD will be multiplied with 1 plus d square once, and then this 1 plus d to the power 4 d to the power 5, this message bit, this message, actually this is not in the bit, this message expression, this message polynomial expression will be multiplied with the second term, which is 1 plus d square. Okay, and there will be the gap. So when we are multiplying this to this two, I'm highlighting this. That means when we are multiplying this, so we have got this. When we have multiplied this with this, okay, then we will generate this. So all the addition is basically considered as a XOR addition. So the same elements will be cancelled out. So D5 and D5, D6 and D6. Okay, so finally we have got C1 and C2 like this. Now our, okay, just let me remove this. Okay, so now we have generated C1 and C2 in the D polynomial form. So here you have to remember that how to write the final answer in your question paper. So in your examination, how to write what is the ultimate answer, which is called the convolutional encoded bit. So this is the procedure. That means C is your final answer. That means which is called convolutional encoded bit, which will be represented as C0, C02. That means C01 and C02. That means 0, the suffix 0 is representing at the 0 instant. At the 0 instant, the value of C1 and value of C2 will be in the side by side, comma. Then C1 and this is also 1. The suffix 1 is representing at the instant 1. That means at j equals to 1, at instant 1, the value of C1 and C2. In this way, at value of j equals to 2 and j of 2, that means at instant of 2, the value of C1 and C2. Okay. So at each instant, we have to write C1 and C2 value side by side. Okay. So to make it we have to make a table. This is for your understanding purpose. So this is C1 and this is C1 and C2. So we're just taking the coefficients. We're just taking the coefficients. We're just taking this coefficients C1 and this is the coefficients of C2. So whose coefficient? That means from this this is 1. The first value is 1. Okay. So 1 is the coefficient of d to the power 0. So as I've written in this, that d to the power 0. So for the C1, the coefficient of d to the power 0 is 1. The d term is missing. That means d to the power 1 term is missing. That means this d to the power 1 term is missing for C1. So that's why this is 0. Okay. Then d2 coefficient is 1. And again d3 is missing, so that's why this is 0. d4 is present, 1. d5 is present, d6 is present, and d7 is also present. So that's why the coefficients of all this, the rest of this is basically 1. As well as C2, so this is 1. 1 is for the coefficient of d to the power 0, and this is d. The coefficient of d to the power 1 is present, so that is 1. D to the power d square is also present, but d3, there is no d3 term, so that's why the coefficient of C2 will be 0. So in this way we have made this table, and for d to the power 0, that means just follow this d to the power 0, we have got the value of C1 and C2 both. So that is basically this value. Okay, that means suffix 0, I have told you that suffix 0 is basically depicting the 0 instant or instant, the value of the j. So at d0, that means at 0 instant, the value of C1 and C2 will be 1 and 1. That means this 1, 1. At d to the power 1, that means when suffix is 1, then C1 and C2 will be 0, 1, because this is 0 and this is 1. Okay. For d2, that means for the third instant, that means d2, that will be the value of 1, 1, because this is 1, 1. So in this way, we have to just write this final encoded convolutional code or output as side by side. Okay, so this is 1, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1. So this is your final answer. So this is the procedure by which you can generate the convolutional coding, convolutional coded bit when we are considering. Just let me erase it. So this is the procedure to generate the convolutional coded bit as output from encoder, or you can say the FSSN. The diagram you have to make, or you will be given. That means when a diagram will be given, then you have to first make the impulse response by this table. So here you can see that from the question, this is written that when it is written in this form, that means cconv equals to 212. So you have to remember that there is a one message input and two output, and the two delays are being used. Okay, K capital is basically defining the delays, the number of the delays we are using. So two delays are using. So that D, that is basically represented by D, that means delay domain. And you will be given also the input in the bit sequence. So when this is given in the bit sequence, you have to convert it to the polynomial, and you have to actually convert the all, that means impulse response also, impulse responses which you have generated in the bit form from this table, that will be also converted to the bit, the polynomial in the D term. Okay, so then when we get both MD and GD, okay, the GD, the final GD will be, should be written in this way, that means side by side. Okay, then the CD will be MD, that means the message input, which is multiplied with the impulses, and in this way you have to just make this table finally, and then you have to write the final answer. So this is the whole procedure considering single input. Okay, just note that this is the diagram. This is the diagram for single input and multiple output. So next, in the next lecture, we will consider multiple input and multiple output. Okay. So I can see you. I can just. Okay. So in the next lecture, we will discuss about the multiple input and multiple output. Right. Thank you for attending these classes. Okay.